Okay, let's look at our second example. These are, again, called indefinite integrals, which is basically the same as an antiderivative. Okay, here's the process. Again, just like we did for weeks looking at the derivative of something, if we have a variable in the denominator or a radical involved, we want to rewrite it. So in this case, we end up with 5x to the negative 1/2 with respect to x. Okay, so this symbol again is the integral symbol, which means we're going to be taking the integral of all of this with respect to x, which is again the same as taking the antiderivative of this. So one of our basic rules says if we have a number in front of a variable expression, we're allowed to put that number in front of the integral symbol, leaving the interior here as just x to the negative 1/2 with respect to x. So the next rule we're going to look at is one that is the most used rule in integration. We've already looked at it once before in the first example. Now we're going to look at it again. So what we're going to do is we're going to bring the 5 down. This is just 5 times whatever we get here. So we're going to end up with 5 times what? Well, here is that rule. All you're going to do when we integrate something now is we're going to add 1 to whatever the exponent is, and then we're going to divide by that exact same value. And we're going to always remember to add c because these are indefinite integrals. So let's see what we end up with. We get 5 times what? X to the positive 1/2 all over 1/2 plus c. So the final answer, when you look at 5 divided by 1/2, that's the same as 10. So we get 10x to the 1/2 plus c. Example C. So again, the same thing applies with all of these. If you can, if it's possible to do so, you want to rewrite everything so that all of your variable x's are in the numerator position. All right, so what this really means is 6x to the 5th divided by x squared, which is the same as 6x cubed. And then this piece, plus 3 over x squared, that means exactly the same as plus 3x to the negative 2. And then finally, this negative x cubed over x squared means the same as just x, or x to the first understood. So now that we have every term in the numerator position and no radicals involved, we are able to use our basic rules of integration to simplify this particular indefinite integral. So I don't know why I wrote that. What we can do now is actually apply what this symbol means to each of these terms. So here's what we get. We get 6x, add 1 to the 3, do that always first. Add 1 to the 3, get 4, and then divide by that new exponent. You're just going to go term by term. So for the second term, 3x to the negative 2, let's look at the antiderivative or integral of this term, which means we do what? Plus 3x to the negative 2 plus 1. Do that first. Negative 2 plus 1 is negative 1. Then divide by that exponent, the new exponent. Then we have what? Minus x. Okay, so again, let's determine the value of the integral of negative x. How do we do that? Well, minus x to the what? It's already understood to be x to the first, so we have to add 1 to that. So you get minus x squared. That's our new exponent. We divide by that new exponent, and we remember to put plus c. At this time, all we have to do is simplify. So we get 6/4 is the same as 3/2. Then add the x to the 4th to that term, and then we have what? Minus 3x to the negative 1, and finally minus x squared all over 2 plus c. Finished with example letter C. Example D. So here again we have an integral of something, okay? Well, we got to make sure this something, what we're trying to integrate, contains only variables in the numerator, if possible, and we have to make sure all our radicals are turned into exponential form. So the first step is to rewrite this as follows. We're going to look at this as the integral of what? X to the 1/2 plus 3x to the -1. Note the changes there. And we're going to keep this the same, minus 2e to the x. Uh-oh, e to the x again. I want you to look at the last two basic rules of integration in your notes so that you know what to do with this particular term, even though I'm going to show you what to do right now. So here we go. We're now going to evaluate this indefinite integral. So again, the process is very repetitive. So just with respect to x to the 1/2, here's what we're going to do. We're going to do x to the 1/2 plus 1. 1/2 plus 1 is 3/2. That's your new exponent. And we're going to divide this by, guess what? The new exponent. Then we move to this one. This is also based on a special rule now that is in your notes. It deals with the natural logarithm. So anytime you take the integral of x to the -1, note that if you just were to add 1 to this, you get x to the 0. Okay, well that doesn't really make any sense. So what we're going to do is we're going to follow the basic rule of integration. And if we ever have x to the -1, here's what we're going to do. First thing is to bring down the 3. The 3 stays the same. But now again, specifically, what is the integral of x to the -1? Well, by rule, it is the natural logarithm of the absolute value of x. So again, the integral of x to the -1 is equal to the natural logarithm of the absolute value of x. Finally, this term would be minus 2. That stays the same. And guess what? Just like for the derivative of e to the x, the integral of e to the x is e to the x. Then you put your plus c, and we're almost finished. Let's go ahead and simplify this, because again, I don't want to have a fractional result here in the denominator. So this really means 1 divided by that, which is the same as 2/3. I still have trouble drawing a 3 deficiency, times x to the 3/2 plus 3 times the natural logarithm of the absolute value of x minus 2e to the x plus c. Wow, that's a lot. But there you go. Example E. So in this case, we are taking the integral of this product. Well, we haven't learned any other special ways of integrating anything yet besides looking at our basic rules. So a good move here would be to think of this first as follows. X to the positive 1/2 times the same quantity here. And so now what we're going to do with this is just distribute this x to the 1/2 through every term in the parentheses. And we're going to rewrite the integral then as follows. Let's see, x to the what? When you multiply like bases, you add the exponents. So 1/2 plus 2 is 5/2. And then minus x to the 3/2. Again, why is it 3/2? Because 1/2 plus 1 is 3/2. We're multiplying like bases here. And then plus x to the 1/2. All right, so then we go through our motions again. A lot of repetition here. So here we go. We're ready to evaluate the integral. And note, if I haven't made it clear already, when you're evaluating the integral, this symbol goes away. All right, this symbol will never be in your answer. This symbol will never be in your final answer. This is telling you what you're doing with this expression. So what we're doing now is what? We're going to do one term at a time. So we're going to add 1 to the 5/2, giving us 7/2. Then we're going to divide by that 7/2. And then we're going to do the same thing for all our terms. So x to the 3/2 plus 1 is 5/2. Then we're going to divide by that new exponent. So on and so forth. Add 1 to 1/2, you get 3/2. Divide by that new exponent. And then remember to put your plus c. And this should not be a positive. Check your work. It should be a minus. Sign should be the same. Okay, so finally, we just invert these denominators and end up with this. 2/7 x to the 7/2 minus 2/5 x to the 5/2 plus 2/3 x to the 3 halves, and remember, plus c. Isn't this so much fun?